Dear children, it is a continuation of the chapter Areas of Parallelograms and Triangle. Now let us start the exercise 2. Let us solve the problems in the exercise 2 of the chapter. The first question is, in the figure ABCD is a parallelogram. AE is perpendicular to DC and CF is perpendicular to AD. If AB equals 16 centimeter and AE equals 8 centimeter and CF equals 10 centimeter, then find AD. Now here, you know the formula to find the area of the parallelogram is base into height. Area of parallelogram equals base into altitude or base into height. You can take any base and its corresponding altitude. Here AE is there. AE is the altitude on the side DC. So you can take the area of the parallelogram ABCD equals DC into AE. Here what is the measurement of the DC? Here AB and DC are the opposite sides of the parallelogram. Therefore DC is also equals to 6 centimeter. And AE altitude is given, and you know that 8 into 6, 48 centimeter square is the area of the parallelogram ABCD. So let us solve it. Write the solution here. Write area of parallelogram equals parallelogram. Before that you write here what are given in the parallelogram or in the figure. What are given? Given that AE equals 8 centimeter, CF equals 10 centimeter, CF equals 10 centimeter and AB equals 16 centimeter. So therefore you can write, also you can write DC equals AB, both are equals to 16 centimeter. Reason you can write opposite sides of parallelogram. Opposite sides of parallelogram. Therefore here AB and CD both are equals to 16 centimeter. Now write the area of the parallelogram. In parallelogram, you write A equals B into H. A equals B into H. So you can take any base and its corresponding altitude. So if you take the DC as a base, its corresponding altitude is AE. AE is the altitude on DC. So you write here area equals, A means here area it is. So area equals, that equals DC is 16 centimeter and AE is 8 centimeter. So area equals 16 8s that you can write, that is 128 cm square. Area of the parallelogram is 128 cm square. Now here if you take any base and any altitude of this parallelogram, the area will not change. The area remains same. Totally the area of the parallelogram is 128 cm square. Here we have to find AD. If you take AD as a base, its corresponding altitude is CF. So by taking AD as a base and this area here, and by using the altitude CF, you will get the measurement of the AD. If B equals AD, B equals AD. Then you write area equals what? 128 cm square. And here H is, altitude is how much? 10 cm. So what you have to find out? AD equals question mark. Then you write the formula for the area, that is A equals B into H. How much is there? That is 128 cm square is there. Then B is AD into H is 10 centimeter. Its corresponding altitude is 10 centimeter into equals 128. So AD equals 128 by 10. Then it becomes 12.8 cm. So what is the measurement of the AD? Here the question is find AD. So AD you got. AD is equals to 12.8 centimeter. Now the second question. If E, F, G and H are respectively the midpoints of the sides of a parallelogram ABCD, show that area of parallelogram EFGH equals half the area of parallelogram ABCD. Here there is a parallelogram ABCD and EFGH are the midpoints of the parallelogram ABCD, and EFGH is also parallelogram, and we have to prove that area of EFGH is equals to half the area of ABCD. Now you write solution here. Given EF, E, F, G and H are respectively the midpoints of the sides AB, BC, CD here you write AB, BC, CD respectively. AB, BC, CD, DA respectively. Join H and F. Know that is HF is parallel to EB and also HF is parallel to CD. Triangle HGF and parallelogram AFCD. HFCD, parallelogram HFCD are on the same base HF, and between the parallels HF parallel to CD. Write triangle HGF, and parallelogram HFCD are on the same base HF, and between the same parallels HF parallel to DC. Therefore, you can write that area of triangle HGF equals half into area of parallelogram AB half into area of parallelogram HDCF. Area of HDCF or HFCD. Here the parallelogram HFCD and triangle HCF are on the same base and between the same parallel. So area of triangle HCF is half the area of the parallelogram HFCD. Similarly, triangle HEF, this triangle, and parallelogram ABFH, and parallelogram ABFH are on the same base HF and between the same parallels AB parallel to HF. AB parallel to HF. So you can write area of triangle HEF equals half into area of parallelogram ABFH. So you consider this is first and this is second. So from first and second, or by adding first and second, first plus second, here you add LHS, that is area of triangle HGF, plus area of triangle HEF equals half area of HDCF, half into area of HDCF plus half into area of ABHF. So here the total of this area becomes the area of HEFG, that is area of EFGH equals half into area of this total area, this area of this plus area of this, you will get the area of the ABCD, half area of ABCD. Therefore you can write that area of EFGH equals half area of ABCD. Now the third question, P and Q are any 2 points lying on the side DC and AD respectively of a parallelogram ABCD. Show that area of triangle APB equals area of triangle BQC. Here P and Q are 2 points lying on the sides DC and AD respectively. And here there are two triangles, triangle APB. This is the triangle APB, and next triangle BQC. This is a triangle BQC, and we have to prove that their areas are equal. Now here you take the triangle APB and parallelogram ABCD. See this triangle and parallelogram. They are on the same base and between the same parallels. Therefore, the area of the triangle APB is half the area of the parallelogram ABCD. So you write here the solution. Here what is given here? Given in the figure P is a point on DC and Q is a point on AD. Here you take in the figure ABCD is a parallelogram. ABCD is a parallelogram and P is a point on the side CD and Q is a point on the side AD. Now you take that parallelogram ABCD and triangle APB. Parallelogram ABCD and triangle APB are on the same base AB and between the same parallels AB parallel to DC. You write triangle APB. Here which triangle is there? Area. Triangle APB and parallelogram ABCD are on the same base AB and between same parallels AB parallel to CD. AB parallel to CD. Therefore, you write if triangle and parallelogram are on the same base and between the same parallels, then the area of triangle is half the area of the parallelogram. Therefore, you can write area of triangle APB equals half into area of parallelogram ABCD. Parallelogram ABCD. Similarly, you take triangle CQB. Triangle CQB and parallelogram ABCD are on the same base. Which base here? BC. Same base BC and between the same parallels. Between the same parallels. Which parallels here? AD parallel to BC. AD parallel to BC. Therefore, area of triangle CQB is half the area of the parallelogram ABCD because they are on the same base and between the same parallels. Therefore, you write area of triangle CQB equals half into area of parallelogram ABCD, same parallelogram. ABCD. So you consider this is 1, this is 2. Therefore from first and second, you can write, therefore area of triangle APB equals area of triangle CQB. Area of triangle APB equals area of triangle CQB. That is from first and second.